Hi, everybody. We have so far talked about simple interest, and now we're going to move on to the next two topics. We're going to talk about compound interest and the future value of an annuity. And on your formula sheet, the two equations that we're going to be looking at right now are this one. This is the formula for compound interest. And if you notice under annuities, there's two different formulas. This one's called the future value of an annuity, and this one's called the present value of an annuity. That's what the PV stands for. So we're going to talk about, in this section, we're going to be talking about the future value of an annuity. So we're going to be looking at these two formulas in this lesson. So make sure you realize that. We'll get to the other formula, the present value of an annuity, in section 3.4. Okay. We haven't talked about either of these topics yet. When I first taught this topic, both compound interest and annuities in Math 1324, I taught them as separate topics. And remember, your test over this material is going to be one big batch of word problems, and you have to go through each situation and figure out what kind of problem you're dealing with. Is it simple interest, or is it going to be compound interest, or is it going to be an annuity? And if it is an annuity, is it the present value of an annuity, or is it the future value of an annuity? Okay. We're going to look at continuous compound interest. We're going to look at amortization, which is paying off a debt. So you've got to know what situation you're dealing with and which formula applies, and then how to work with that formula. So when I first taught 1324, and I taught compound interest and the future value of an annuity together or separately, I found that like when test time came around, people were still getting confused between the two. So I thought it would be a much better idea to try to teach these two topics together so that you can, from the get-go, see the difference between them. Okay. In a nutshell, these two formulas for compound interest and the one for the future value of an annuity, you are going to use these when you are saving money. Okay, so in both cases, you are saving money. The big difference is how you save the money. Okay, so with compound interest, what happens is you make a one-time deposit, and you let that money sit there in the bank or whatever account it is, and you let it earn interest. And then you come back after so much time and you see how much money is there. Okay, it's your original amount plus any interest that has been earned. Okay, in the case of an annuity, when you're saving money this way, it is more than just a one-time deposit. You are actually making regular deposits into your account. Okay, in both situations, we assume that we don't withdraw any money, so that's important too. So here you are making regular deposits. So an example might be, if you have a steady paycheck coming in, you may have $50 withheld from each paycheck and automatically deposited into a bank account. So you're making these regular deposits of $50 maybe every month when you are paid. And so your account earns interest, and then you're also getting money from these regular deposits. Okay, so that is the big difference. Okay, so again, okay, both of these formulas you want to use when you're saving money. Okay, the difference between the two is how often you make a deposit. The compound interest formula is a one-time deposit. Put the money in, you forget about it. You come back after so much time, you see how much money you have between the original deposit and the interest. With the future value of an annuity formula, okay, you're making regular deposits. Okay, so your money is growing through those regular deposits, and then any interest earned on those regular deposits. Okay, so the first thing we're going to do in example one, we're going to look at compound interest. Okay, I'm going to give you a scenario, and we are going to map it out. Okay, And then we're going to do the same exact scenario, but from an annuity perspective, so you can see how the two situations differ. Okay, so let's go ahead and read this. And again, in example 1, we're going to look at how compound interest is handled. Okay, so it says, suppose you open a savings account at Bank of America and you deposit $1,500 at 4.8% compounded quarterly. Assuming that you do not withdraw any money and do not make any further deposits, what is your account balance after 1 year? Okay, so make sure you read through the problem and understand before watching the rest of this. Okay, so what's going to happen here is you are going to Bank of America and you're putting in $1,500. Okay, you have a 4.8% interest rate. Okay, and that is compounded quarterly. Okay, when you're doing these problems, okay, now that you're out of the simple interest section, you're going to start seeing this phrase a lot. Something like compounded quarterly, compounded monthly, compounded yearly, and so on. Okay, that phrase is going to be in all problems with the exception of simple interest. Okay, so don't automatically jump the gun and say, oh, I see the phrase compounded quarterly, that's a compound interest problem. That is not how this works. The same phrase compounded quarterly will be in example 2 when we are doing the annuity problem. Okay, so the word compounded, all that means, I'm going to write it up here, compounded means the interest is added to the account. So in this case, the interest is added to the account. It's compounded quarterly, so that means the interest is being added to the account 4 times a year. Okay, so we know that if we're talking quarterly, okay, we don't think in quarters, at least, well, businesses do, but I guess in everyday life, we don't tend to think in quarters so much. We might think months. There's 12 months in a year, and you're dividing it. Think of quarter is 4. Okay, I think there's 4 quarters in a dollar. So if you divided it by 4, that's every 3 months. Okay, so 1 quarter is 3 months. Okay, so what you see here, okay, I've got 12 months mapped out. You can see the word month. So this is representing 12 months or 1 year. And I have them separated by increments of 3 months. So this is the first 3 months, the second quarter, third quarter, fourth quarter. Okay, so it's broken up in the 4 quarters of the year. Okay, because each line is the way you can think of this line. Okay, well, let's start from the beginning. So this first vertical line appears, you know, right at month 1. So if this were a year, you could think of this as the beginning of month 1. So let's just pretend that this is a full year from start to finish. Okay, so that might be January 1st, and then the 3 months pass, and that brings you, this is January, February, March. This might be the end of March, so you're thinking March 31st here. Okay, and again, it doesn't have to go from January 1 to December 31st, but we're just assuming that here for, you know, visual purposes for me explaining this to you for the first time. All right, so then another quarter passes. This is going to be April, May, June. Okay, the line appears after June, so this might be June 30th. Okay, so this is the second quarter. Okay, here's the third quarter, July, August, September. So end of September would be September 30th. And then you have the last quarter of the year. So this is October, November, December. And that brings you to the last day of the year, December 31st. Okay, so remember, you're putting your money in at the beginning of the year. Okay, and it's going to sit in there for an entire year. And your money is going to earn interest. So you're not taking anything out. Okay, it tells you assume that you don't withdraw any money. So at the end of the year, you're going to have more than $1,500 because your money is going to accrue interest. So what we're doing is we're going to map out how this happens. Okay, the interest is compounded quarterly, so every quarter, at the end of every quarter, you should be getting an interest payment. Okay, so we're going to see how this works. Okay. All right. So January 1st, we're going to go ahead and put our money in. Okay. So you're going to put $1,500 in the bank. Okay. And then the interest is accrued at the end of every quarter. Okay. So all you do is put the money in. Okay. Then you have to wait for a quarter to pass. Okay. So your money sits in there January, February, March. March 31st hits, you're going to get an interest payment. Okay. So we're going to calculate, okay, at this line in March 31st, okay, how much is in our account at this point. Okay. Sometimes your bank will even send you a statement like when you get an interest payment. So, you can kind of keep track of how they're doing this. All right, so we need to figure out how much interest we've earned in this quarter, okay? So to calculate interest, you're going to do what you did for simple interest. In this past 3 months, it's been earning interest, and that's just the principal times the rate times the time, okay? So my principal is I had $1,500 in the account. The rate is 4.8%, but remember you have to work with that as a decimal. So drop the percent sign and move the decimal point 2 places to the left. So it's going to be 0.048, okay? And then the time, the money's been sitting in there January, February, March, so 3 months. Okay, so remember you have to use 3 over 12, 3 months out of 12 for the time. If you used just a 3, then that would be 3 years, and that is incorrect. You want it to be 3 months, okay? So put this into the calculator, okay? So we're going to get 1,500 times 0.048 times 3 over 12, okay? And that's your answer. It comes out to a nice, even $18. That's how much interest you have earned in the first quarter, okay? So we earned $18, okay? And so our total amount on March 31st, the end of the quarter, is going to be what we started with, the $1,500 plus the interest. So we end the quarter with a total of $1,518, okay? All right, so you don't take any money out, okay? So this amount starts earning interest over the next quarter through April, May, and June, okay? So this money, this amount sits in your account, okay? And then we reach the end of June, and that is when you're going to get your second interest payment, okay? So again, to calculate the amount of interest you've earned in the second quarter over April, May, and June, you're going to do I equals PRT, okay? So you're going to take your principal is how much money you had in the account during the second quarter. During the second quarter, you had $1,518 in there, okay? You need to multiply that by the rate, which is still 0.048, okay? And that $1,518 sat in there for 3 months, April, May, and June. So again, 3 out of 12 months, okay? So now we're going to plug this into the calculator to get our interest payment for the second quarter, okay? So let's see if I can make sure you see this. Okay, so we're going to have 1,518 times 0.048 times 3 over 12. And so now you get some decimals appearing here, okay? So remember, what is your bank going to do? If you got a statement at the end of June, okay, this is not the number you're going to see. This is, money has to be dollars and cents, okay? So you need to round this to the nearest cent, okay? So we're going to have $18 and 21 is the cents here. You need to look at the 6. The 6 means to round up. So this is going to be $18.22. Okay, that's how much interest you earned during the second quarter. Okay, all right. So the total amount in the account after or as of June 30th, okay, is going to be what you started with at the beginning of the quarter, so $1,518 plus the $18.22 of interest that we have earned. Okay, so if you add those two numbers together, okay, you're going to get $1,536 $1,005,036.22. Okay, so as of June 30th, end of the second quarter, that's how much money is in the account. Okay, now that money, this amount is going to sit in the account during the third quarter, July, August, and September. On September 30th, the end of the quarter, you will get your latest interest payment. Okay, so let's go ahead and calculate it. Okay, your interest will still be principal times rate times time. Okay, so during the third quarter, $1,536.22 sat in the account. Multiply that by the interest rate times the time. Okay, again, 3 months, July, August, September. Okay, so let's go ahead and plug this into the calculator. Okay, this is going to give us, let's see here. All right, so we're going to get $1,536.22 times 0.048 times 3 months out of 12. Okay, so again, you need to round this to the nearest cent. This is going to be $18.43. Remember, since this is a 4, you want to round down or keep it the same as what we mean by round down. So $18.43 worth of interest. Okay, now figure out your account balance. I'll write it, let's see, I'm kind of running out of room here. I'll write it right here. So the account balance as of September 30th is going to be what you started with. So you started with $1,536.22. Okay, and now we're going to add the $18.43. Okay, to get our account balance. Okay, so let's see, this is going to be okay, we end up with $1,554.65 at the end of the third quarter. Okay, our money has to sit in there one more quarter, so this amount will make interest over October, November, and December. Okay, you get your last interest payment on December 31st, so we need to see how much that is going to be. Okay, so let's go over here. On December 31st, you'll get your last interest payment. That's going to be PRT again. Okay, so that's going to be the amount that sat in there for the fourth quarter. So $1,554.65 times the rate times the time of 3 months. Okay, let's go ahead and plug and chug this one. Okay, let's see. This is going to give us $1,554.65 times the rate times the time. Okay, round this to the nearest cent. Okay, so this is going to be $18, and look at the second 5. That means you need to round up. Remember, you round up if it's 5 or greater. You keep it the same if it's between 0 and 4. Okay, so we're going to get $18.66 worth of interest. Okay, and now to get our final balance, how much money we have in the account at the end of the year, okay, we just need to add. So we're going to take what we started with in the fourth quarter. We started with $1,554.65. Add the interest that we earned, $18.66. Okay, so the grand total at the end of the year is going to be this, $1,573.31. Okay, so that's how much money we earned over that 1 year. Okay, all right, so that's the answer to the question. Okay, I'm trying to figure out where I should write it. I'll write it right here. The answer to the question, again, is the fourth quarter total, $1,573.31. Okay, because again, it asks for the account balance. Okay, so remember, you deposited, your initial deposit was $1,500. So if you subtract that out, that means you earned $73.31 worth of interest over that 1 year time period. Okay, all right. In example 2, we are going to rework this example that we just mapped out, but we're going to use the formula for compound interest. Okay, Obviously, this mapping out process, it really helps you understand what's going on behind the scenes, but it's not feasible, okay? This was just saving money for 1 year with the interest compounded every quarter. Imagine you were doing this for like 25 years and you were compounding the interest monthly, okay? You can't map this out. You're going to have to use a formula to get your amounts, okay? So if you look at your formula sheet, okay, the formula for compound interest is A equals P times 1 plus R over M to the MT. Okay, and I know, we talked about that this is compound interest, but again, why is this a compound interest problem? This is a compound interest problem because we had a one-time deposit of $1,500. We let that money sit there. We put the money in one time and we forgot about it. And we came back at the end of the year and we said, hey, how much money do I have? Okay, one-time deposit, saving money, that's a compound interest problem. Okay, all right, so what do these variables mean? Okay, well, R is going to be, let me write that under here. R is your interest rate, has to be a decimal. Okay, M is the number of compoundings per year, meaning how many times per year is the interest added to the account. Okay, T is the time in years. Time is always measured in years in these problems. Okay, P is the amount of the deposit, because remember you're making a one-time deposit. And then A is the account balance. All right, so that's what all these guys stand for. Okay, so since we are looking for, the question asked us to calculate the account balance after 1 year, okay, we would be looking for A. Okay, if we're looking for A, that means we should know the value of all the other variables. Okay, so we do. Okay, so let's go ahead and figure this out. We're looking for A, the account balance. Okay, P is the amount of the deposit I made. I put in $1,500. That's my one lump deposit. Okay, we're going to plug in the other variables. The R value is the interest rate, has to be a decimal, so it's going to be 0.048. You need to divide that by the number of compoundings per year. Okay, the interest was compounded quarterly, so every 3 months is 4 times a year. Okay, so for quarterly, we're going to use M equals 4, okay, because it's 4 times a year. Okay, you're going to raise this guy to the 4 times T power. The number of years you kept the money in the account was 1 year here. Okay, all right, so you've got to enter this into the calculator to get your answer. Okay, so make sure you pay attention. Every time we do a problem, I will show you how to put it in the calculator, especially as the formulas get more complex. Okay, you're basically going to type it in as you see it. Okay, so make sure I can get all this in here. Okay, so we're going to type it in exactly like you see it. Okay, so you're going to have 1,500 parentheses 1 plus R over M raised to the, now the exponent, you can do that in your head. You know it's going to be 4. Okay, 4 times 1 is 4. But I want you to get in practice of, a lot of the times the exponent won't be simple and you won't be able to do it in your head. So get in the habit of putting your exponent in parentheses, especially if you have an older calculator. If you don't, it's not going to come out correctly. Okay, so this is how you should enter it in. Okay, and notice what you get. Okay, again, you're going to want to round your answer to the nearest cent, dollars and cents. Okay, so we're going to have $1,573, and we have 30 cents, but the number after the 0 is a 6, so we need to bump it up to 31 cents. And that's exactly what we got when we mapped out the problem in example 1. Okay, so now we will switch gears and look at this as an annuity